Hello, my name is Brian Dick. I am a software engineer, and this is my YouTube tutorial series on solving the HackerRank interview preparation kit problems. Currently, we're going over dictionaries and hash maps, and today's problem is count triplets. While this problem is only considered a medium level problem, I would argue that this is harder than most hard problems that I've seen on HackerRank. And it is actually very confusing logic. So let's read this carefully and then see if we can try to understand this a little bit better. Okay, so with that out of the way, let's get to the problem. You are given an array and you need to find a number of triplets of indices I, j, k, such that the elements at those indices are in geometric progression for the given common ratio of r, and I is less than j is less than k. For example, if we have an array 1, 4, 16, and 64, if r is equal to 4, we have 1, 4, 16, and 4, 16, 64 at indices 0, 1, 2, and 1, 2, 3, respectively. So for our function description, complete the count triplets function in the editor below. It should return the number of triplets forming a geometric progression for a given r as an integer. Count triplets has the following parameters: r, an array of integers, and r, an integer, the common ratio. Okay, so what makes this problem so complicated is much like the hard problem found in the arrays section of the interview preparation kit. The issue is not necessarily having a solution. The problem is having a efficient solution. So the biggest issue with this problem is the fact that the brute force in this case is absolutely horrendous. Effectively, if we were to try to brute force this, we would need to have 3 loops that loop through the entire array at different staggerings so that we can check one ahead or like n ahead and see if at any point we have this triplet behavior. And then we would have to try to use maybe some backtracing or some. It's just really ugly. And even that's a complicated solution. Since this is dictionaries and hash maps, the idea is pretty simple. We're going to use a dictionary or a hash map to make a very quick lookup, and then we're going to do something smart to figure out how many pairings it creates at the third step of it. So effectively what we're going to do is we're going to create 2 maps, and I'm going to put comments in this one because this one's kind of complicated. So we need 2 maps. So the first map is going to keep track of what we are looking for and how many pairings we gain if found. Okay, so what I mean by this is we're going to have a seeking map. And this is going to be a map of integers too long, where we are seeking a number of pairings that if we find a number, so once we find a number I, an index into the array at I, we are going to look for something that's that value times r and determine, and we're going to set at that position a increment of that key. And then if we ever find this key, we're going to say in our second map, we're going to also have a map of int and long, that if we find this one, so like it'll be basically a map. So let's just make it so like an std map int long, and then we're going to have the first one second nums or second num table, and then a third num table. So the idea is this second num table is going to have the numbers. If we were to multiply by r and we find this, how many potential pairings we could arrange with the indices of the second number from the array sub I location. Then our third num table is if we find the number that is in the third num table, if we have a key that equals this number at some point that comes down the array down the line, then that's going to be a completion of a triplet. And then at the completion of that triplet, we can add that number to our total num of triplet count. And I'm probably butchering how I'm explaining this. Maybe it'll make a little bit more sense to go a little bit farther. So let's go ahead and create a long, and we'll call this num triplets. And we're going to start off at 0, obviously. Then we're going to do a for int I is equal to 0. And we're just going to iterate through the array linearly. While I is less than r dot size, and increment I. So we're just going to iterate through this, and we're going to first check to see if we have this number in our third num table. So this third num table is a number that we're looking for to be our third number. So if third num table dot find, oops, not dash, dot find ri. So if this is not equal to actual pairings dot end, that means we have found it. In that case, we're going to say our num triplets plus equals the value we hold at this key. So third num table array sub I. So essentially what we're storing in this num table is the key is the number and the value is how many triplets we would have if we find that number. And our other conditional here is if our second num table can find it. So in this case, so not equal to second num table dot end. So in this case, then in our third num table, we're going to look at the point that is array sub I times r. So basically the next number we need, so the third number we need, this is going to complete a number of triplets that is equal to the value being held at this second number. So the second number, second num table at array sub I. So this value that is at this second num table will complete that many triplets if we ever find a key to this. So if in our array we eventually find the key up here, then we get to add that number of pairings that we've found with the numbers preceding it. And then that same logic follows for every number. So our second num table, so we're always going to find 1, right? So we always find I, or array sub I. So if from array sub I times r, so a factor of r from whatever is at this index of the array, we will say plus plus because it'll be incremented by 1. So we'll have the potential in the second num table to complete a single triplet if we find this second number. And then if from the second number, so like let's say we have just 1 to 4, right? So 1 comes through, we don't have it here, we don't have it here. We do have it, obviously we have the number 1. So if we find the number 1 times r, which in this case our r would be 2, then we would be putting in our second num table a key of 2, and we're going to put the value 1 there. Because if we find the 2, then we would be able, and then we find a 4, we'd be able to say we have 1 triplet. So then we'd go through a second time. Let me make a notepad here. Let's see if I can pull one of these up, because it's pretty confusing. So on loop 1, let me make that way bigger. Let's go as big as it'll let me. So loop 1, and let's say this is our input, and our r is equal, and r equals 2. So loop 1, on our first loop, we're going to go to if it's going to have in our second, so we have our, so we'll also keep track of our second num table and our third num table. Let's do this. Like that, maybe. There. So do this. So everything inside of these will be pairings, and yeah. So we go through our first loop. So on our first loop, and I'll just copy, paste these. So we start off, everything's uninitialized. That's our arrays up here, 1, 2, 4, and r is 2. So we go through loop 1. So loop 1, our val is equal to 1, right? And we can't go into any of the ifs. So we then put in in our second table, we put our value times our r, and at that key, we increment it by 1. So we would place 1 there in this case. And let's go back to that. So now our second table has a key of 2 and a val of 1, right? Then we go through a second loop. So on the second loop, we now have the value of 2. So loop 2, val is equal to 2, and we don't find it in our third val, our third num table, but we do find it in our second num table. So then we say in our third num table, we're going to take that and multiply it by r and use that as a key and set that value to, we're going to increment that key by the amount of the second table value. So we're going to then have a third table where now we have 4 because that's 2 times 2. And then we are adding to what is now 0, a 1 to it. So we got a 1. So now our second num table is 2, 1, and our third num table is 4, 1, meaning if we find a 4 on our next loop, then we will add to our number of triplets this value. And sure enough, loop 3 comes along. Our val is now equal to 4, because that's the fourth value here. We go into that first loop, and we immediately see that we immediately see that it's a key that exists. So then we take our number of triplets and we increment our number of triplets by the value found there, which in this case would be 1. And then the loop terminates and we return 1 because we have a single triplet. So that is the logic on a very small scale of what's happening here. So by the time we get all the way down to the bottom of this loop, we have already secured all of the triplets that we would have, and all that's left to do is return the num triplets, like so. And we'll go ahead and give this a run, check all the errors I made. Oh, what did I do? Oh, I used actual pairings. This is supposed to be third num table. Let's try that. There we go. So we passed all 3 of our sample test cases there. And now let's go ahead and submit our code. And what's really nice about that is this solution runs in n time complexity, which is quite nice. And there you have it. So we have completed this very difficult problem, in my opinion, the count triplets problem. If this solution helped you, please give this video a thumbs up. If you have any further confusion or further questioning that you'd like to ask, leave that in the comment section below. I'll try to get back to you as soon as possible. If you want to continue getting help and walkthroughs on the HackerRank interview preparation kit, subscribe to the channel and hit the notification bell. I'm going to be going through the entire interview preparation kit, problem by problem. So go ahead and subscribe. Thanks for watching, and until next time.